Scientists have confirmed that everything you have ever seen, touched, or measured in your entire life, every star, every planet, every atom, makes up less than 5% of the universe. Nobody knows what the rest is, and that should terrify you. The smartest people on the planet, scientists who have dedicated their entire lives to understanding the cosmos, openly admit they have no idea what most of the universe is made of. That is not a metaphor. That is a literal statement about our collective ignorance. And honestly, it should fascinate you in equal measure. Today, we are going to travel through 5 of the most mind-bending, sleep-stealing, sanity-questioning mysteries that the universe has thrown at humanity. These are not fringe ideas from conspiracy theorists. These are questions that haunt the world's greatest astrophysicists and cosmologists every single day. Buckle up, because some of what you are about to hear is going to fundamentally change the way you look at the night sky. Let's start with the one that immediately breaks your brain. Look around you right now. The chair you are sitting in, the screen you are watching, the planet beneath your feet, every star, every galaxy, every nebula, every single thing you have ever seen or touched or measured in the history of human observation. All of it combined accounts for less than 5% of the total content of the universe. So what makes up the other 95%? Something called dark matter and dark energy, 2 of the most frustratingly mysterious entities in all of science. Dark matter makes up roughly 25% of the universe, and here is the wild part. We know it exists without ever directly detecting it. We cannot see it. It does not emit light. It does not absorb light. It does not reflect anything back to us. It is essentially invisible by every traditional means of detection we possess. So how do we know it is there? Because of what it does to the things we can see. Without dark matter, galaxies would literally fly apart. The visible matter, the stars and gas and dust inside a galaxy, simply does not generate enough gravitational pull to keep everything bound together. Something else is doing that work, and that something is dark matter. We can also see its fingerprints in the way light bends as it travels through space. When light passes near regions where dark matter concentrates, it curves in ways that reveal the invisible mass lurking there, a phenomenon called gravitational lensing. It is like detecting a ghost by watching what the ghost moves around it. Then there is dark energy, which takes things to an entirely different level of strange. Dark energy makes up approximately 70% of the universe, which means it is the dominant thing in existence, and we understand it even less than dark matter. Back in 1929, Edwin Hubble discovered something shocking. Distant galaxies were not just moving away from us, they were moving away from each other, and the farther away they were, the faster they receded. This was the discovery that the universe is expanding. But here is where it gets even weirder. Scientists later found that this expansion is not slowing down. It is accelerating. Something is actively pushing the universe apart faster and faster over time. And whatever that something is, it seems to be an intrinsic property of space itself. As space expands, dark energy does not dilute. It grows stronger. We have multiple hypotheses, some involving exotic particles, some treating it as a feature built into the fabric of space-time, but none of them fully explain what we are actually dealing with. This is our universe, and we cannot account for 95% of it. Remarkable. Now let's move to a mystery that is arguably even more existential. Why do you exist? Not in the philosophical sense, but in the most brutally literal physical sense. Why does anything exist at all? This is the antimatter problem, and it is genuinely one of the most unsettling puzzles in all of physics. Here is what we understand about the early universe. In the moments following the Big Bang, particles were created in pairs. For every particle of matter born, a corresponding particle of antimatter was also born, identical in almost every way, but with opposite charge. When matter and antimatter meet, they annihilate each other completely, converting entirely into energy and leaving nothing behind. Now here is the problem. If the universe produced equal amounts of matter and antimatter at the beginning, which is exactly what our most fundamental equations predict should have happened, then everything should have wiped itself out instantaneously. The entire universe should have become a vast ocean of light with absolutely nothing physical remaining. No galaxies, no stars, no planets, no you. Yet here we are. Matter survived, which means at some point during the universe's earliest moments, conditions slightly favored matter over antimatter. For every billion pairs that mutually annihilated, there was one lone matter particle left standing with no antimatter partner to destroy it. Those leftovers became literally everything. Scientists at facilities like CERN are actively hunting for differences in how antimatter behaves compared to matter, testing whether the laws of physics themselves treat the two differently in subtle ways we have not yet measured. So far, the asymmetry that would explain our existence remains elusive. Stay with me here, because what's coming next makes the antimatter problem look simple by comparison. If this kind of content makes you see the world differently, subscribing means you will never miss what we explore next. Our third mystery takes us to the edge of everything we can possibly know, and then asks what comes after. The observable universe spans roughly 93 billion light-years across. That sounds enormous, and it is, but it is not the whole universe. It is simply the portion of the universe from which light has had enough time to reach us since the Big Bang. Beyond that boundary, there is more universe that we will never, ever see. Not with better telescopes, not with more advanced technology. The information from those regions cannot reach us because the universe is expanding faster than light can travel across those distances. So what is out there? Maybe the universe extends infinitely in all directions, filled with galaxies and stars, essentially like the ones we know, potentially repeating patterns across an incomprehensibly vast space. Or perhaps the universe curves back on itself like the surface of a sphere in a higher dimension, meaning if you traveled far enough in one straight line, you would eventually return to where you started. We genuinely do not know which of these is true, or whether the answer is something else entirely that we have not yet conceived of. The laws of physics as we know them might not even apply in the unobservable regions. The rules could be different. Reality itself could work differently somewhere beyond the cosmic horizon. Let's talk about black holes, because black holes contain within them what might be the single greatest breakdown in human understanding ever encountered. At the center of a black hole lies something called a singularity, a point of theoretically infinite density where the known equations of physics stop working completely. Not approximately, not with significant error bars, they stop working. Our mathematics breaks down entirely. The event horizon surrounding this singularity marks the point of no return. Cross that threshold and nothing, not matter, not light, not any signal of any kind, can ever escape back out. General relativity, our best theory of gravity and space-time, describes what happens inside reasonably well up to a point. But at the singularity itself, it generates nonsensical infinities, which as physics speak for our model, has catastrophically failed. Making this even more philosophically disturbing is the black hole information paradox. Quantum mechanics, which governs everything at the subatomic level, has a foundational rule. Information cannot be destroyed. It can be transformed, scrambled beyond practical recovery, but it must persist in some form. Yet when matter falls into a black hole and presumably reaches the singularity, that information seems to vanish entirely. General relativity and quantum mechanics, the two most successful and rigorously tested theories in the history of science, directly contradict each other when it comes to black holes. Resolving this contradiction is considered one of the holy grails of modern physics. And finally, we arrive at perhaps the grandest mystery of all, the Big Bang. Everything, and I mean absolutely everything, space, time, matter, energy, the laws of physics themselves, all of it appears to have erupted from an incomprehensibly small, hot, dense point approximately 13.8 billion years ago. The universe has been expanding and cooling ever since, gradually forming the structures we observe today. We have extraordinary evidence for this. The cosmic microwave background radiation, essentially the afterglow of the early universe captured when atoms first formed around 380,000 years after the Big Bang, gives us a snapshot of the infant cosmos. The James Webb Space Telescope has been revolutionizing our understanding of how early galaxies formed. The evidence for the Big Bang as the origin of our universe is genuinely overwhelming, but the Big Bang itself is where our understanding hits an absolute wall. What happened before it? What caused it? Our current laws of physics cannot describe the singularity from which everything emerged, and they certainly cannot tell us what existed before time itself began. Was there a before? Does that question even make sense? And perhaps most provocatively, is our universe the only one? Could the Big Bang have been just one of countless such events, each producing a separate universe with potentially different laws of physics, a vast multiverse of which we can never directly observe any other member? Here is what strikes me most powerfully about all 5 of these mysteries. They are not gaps at the margins of our knowledge. They are gaping chasms, sitting right at the center of our understanding of reality. We do not know what 95% of the universe is made of. We cannot explain why matter exists at all. We cannot see or know what lies beyond our cosmic horizon. We cannot reconcile our 2 greatest physical theories when it comes to black holes. And we cannot explain what birthed the universe or what came before it. Every answer we find seems to generate deeper, more bewildering questions. And maybe that is the most profound thing of all. Perhaps we are, as some have suggested, the universe itself slowly becoming aware of its own existence, asking questions that may take millions of years and civilizations we cannot yet imagine to finally answer. The universe keeps its deepest secrets jealously, but we keep asking. And that, more than anything else, might be the most uniquely human thing about us. These mysteries are far from solved, and neither are we. The video on your screen right now was chosen just for you, so stay in the session and keep exploring. And if you have not subscribed yet, now is the perfect time. There is a lot more universe to unpack together.